We're going to talk about calculating pH and hydronia and concentrations today. So we've already seen in our equations, we've seen that water can act as an acid and a base. It depends on what it's being combined with. And so, and actually, when it's by itself, if you have pure water, it actually ionizes itself also, so it doesn't stay as a molecule form.
Students going to State Quiz Bowl in Eldridge, Nebraska are now dismissed.
Good luck at Quiz Bowl. So we have the ion product constant of water. It's the concentration of, and that's called Kw. Kw is the product of the molar concentrations of H3O plus and OH at a particular temperature. So at 25 degrees Celsius, if you take the hydrogen or hydronium, and we interchange H3O plus and the H plus symbol, they're interchangeable. And whenever you see the brackets around, so in that box you see how H plus and OH have brackets around them, the brackets mean concentration. So we're taking the concentration of the hydronium concentration times the hydroxide concentration. And for water, that always equals 1 times 10 to the negative 14. So Kw is equal to 1 times 10 to the negative 14. If the hydronium and hydroxide concentrations are equal, that means that the concentration of hydronium would be 1 times 10 to the negative 7th. Hydroxide would also be 1 times 10 to the negative 7th, and the solution would be neutral. If the hydronium concentration is larger than the hydroxide concentration, that solution is acidic. And if the hydronium concentration is less than the hydroxide concentration, the solution is basic. Now remember, your exponents are negative, so large exponents, large negative numbers in the exponent mean that the number is actually small, correct? Keep that in mind. So what would the concentration of hydroxide ions in a hydrochloric acid solution whose hydrogen ion concentration is 1.3 molar? So we can find the concentration of hydronium or hydroxide because of the Kw is equal to the hydronium concentration times the hydroxide concentration. And what is Kw? What's the value for Kw?
1 times 10 to the negative 14.
And that's equal to, we have the hydrogen ion concentration, so I'm going to put 1.3 molar times, we do not know the hydroxide concentration. And actually, I usually, yep. So you would divide, and what do you get?
Get a number. 7.69 rounded to 10 to the negative 15.
So would that solution be acidic or basic? Is 1.3... Okay, our hydronium concentration is 1.3. Our hydroxide concentration is 7.6 times 10 to the negative 15. Which one's larger? Which one's larger? 1.3 is much larger than this number, isn't it?
Oh, it's to the negative 15.
Right, remember our exponents, so times 10 to the negative 15. We're like 0.0000, 14 zeros and 769. So hydronium, our H plus concentration is much larger, so that means that the solution is acidic. Yes. Okay, what is the hydronium concentration of a solution if the hydroxide concentration is 5.0 times 10 to the negative 8th?
1 times 10 to the negative 14
times, and we know the hydroxide concentration is this number. So hydronium concentration is, make sure you use parentheses,
2 times 10 to the negative 9. Actually, it should be 11.
9?
Well, it's 200 times.
Negative 7.
Come on. You got one.
So, is this acidic or basic?
I don't know.
Well, which one's larger?
The 2 is.
Yep, 2 times 10 to the negative 7th is larger. So that would make it acidic, yes. So you have to remember that the exponents are negatives. The concentration of hydroxide ions in a certain household ammonia cleaning solution is 0.0025 molar. Calculate the concentration of H plus ions. So we have 1 times 10 to the negative 14th equals, we're trying to find this. So is this acidic or basic? Basic. The hydroxide concentration is larger, which means that it's a basic solution. Okay, pH scale. I'm sure you're fairly familiar. Did you talk about the pH scale in physical science?
Definitely.
Yeah. Okay, so it's a measure of the hydronium concentration, and it indicates the acidity of solution. And it ranges normally from 0 to 14. Now we will see some where you can go above 14, but you will be able to see a few like that. So the pH is equal to, it's all based on logs, and so it's a negative log of the hydronium concentration. So we've been finding and solving for hydronium concentration. All you do is plug that number into this equation. The negative log of the hydronium concentration is equal to pH.
Are they all going to be log base 10?
Yeah, we're using base 10. So if a solution is neutral, what's the pH? 7. Well, we already know that the two concentrations are equal. There we go. What if it's acidic? Well, let's go through this whole, since we have all this. That means that hydronium concentration is greater than or less than? Greater than. And so hydronium concentration would be greater than 1 times 10 to the negative 7th. And the pH would be less than 7. Basic solution, that one came right away. And so hydronium concentration would be less than 1 times 10 to the negative 7th, and the pH would be greater than 7. Yes. That is. Okay. Now, we can also, so to solve the other way around, so let's say they give you the pH and they need you to find the hydronium concentration. In order to do that, you take 10 to the negative pH, right, to solve for hydronium concentration. If you have 7 equals the negative log of x, how do you solve for x? 10 to the negative x, right? Since it's a negative log. So hydronium concentration is equal to 10 to the negative pH. And we can do the same calculations with hydroxide. We just don't use those numbers. You don't hear of those numbers as much. So we also have a POH, just like a pH, but you're taking the negative log of the hydroxide concentration instead. You could also, if you wanted to find hydroxide concentration, would equal 10 to the negative POH. And since the two concentrations multiplied together is equal to 1 times 10 to the negative 7th, the two pHs added, the pH and the POH added together should give you 14. So by using all of these equations, we can use a combination of them. There are going to be usually 2 different ways you can solve the same problem for this right answer. And it's just whichever way you feel more comfortable with or you like. It doesn't matter to me. Okay, first we're going to identify if it is acidic, basic, or neutral.
Acidic.
So the first one, acidic. Pancreatic fluid,
Super acidic.
yeah. This is less than 1 times 10 to the negative 8th, right? Or 1 times 10 to the negative 7th. So that would make it basic, yes.
Acidic.
This is acidic. pH is probably a little easier to figure out if it's acidic. Neutral. How could we also, if you like looking at pHs better, you could convert this into a pH and do that. And the pH of this one would have been 8. No, isn't this one acidic? But this is the hydroxide concentration. So the hydroxide concentration is going to be less than the hydronium concentration. That makes sense to see. And this one, yes, is basic. Questions on those? Okay. pH of a rainwater collected in a certain region of the northeastern United States on a particular day was 4.82. What's the hydronium concentration of that water? Uh-huh. And that's it? Okay, there you go. That's it. Okay, the hydroxide ion concentration of a blood sample is 2.5 times 10 to the negative 7th molar. What's the pH of the blood? But this is hydroxide. It gives us the hydroxide, and it's asking for pH. So we can't just plug that number into our pH equation.
You can plug it into the negative log of 08 and subtract that to 14.
Ah, okay, so if we did negative log of OH, that means this is not pH. This would be POH. What do you get? Negative 7, yeah. 7.4. Okay.
So we have to subtract that from 14.
Oh, okay. So your pOH is 6.6. Okay. 6.6. So then we can say that pH plus pOH is equal to 14. So if we plug 6.6 in for pOH, so 14 minus 6.6 makes our pH 7.4.
So how did you get that 6.6?
The negative log of 2.5 times 10 to the negative 10th. Or 7th, yeah. Of the. Now, what's the other way we could have done this problem? There's two ways. We could have first solved using our KW equation, solve for H plus concentration. So taking 1 times 10 to the negative 14th and divide by the 2.5 times 10 to the negative 7th, and then use that number in our pH equation. Yep. Uh-huh. Mm-hmm. When we took the 10 times 10 to the negative pH, when you actually punch that into your calculator, 10 to the negative 4.8 gives you that number. Since it's not a whole number in the exponent, it's not going to give you a whole number out front. Okay, so two different ways you could solve that. Two more problems. Let's see. Let's have the two rows over on the right. So Ben's row and Colby's row, you guys have the first problem. And Josh and Ben's rows, you guys have the second one. Negative 4. This to the other two to the left. Yeah. Since it's 2.9, you should technically have 2 decimal places. There's some different rules when you do logs and stuff and exponents that we didn't talk about for significant figures, but. Okay, who wants to write up their answer in the first group or second group? Anyone ready in the first group? Yeah? Let's see. What?
Because it's the same process for the second.
Oh, wait, no, yeah, because your H is going to be. No, I think this is.
H3O plus is the same as H plus.
But don't you use this?
Yeah, you can.
You can.
Yeah.
But you can just do the negative log.
Of the H plus concentration will give you the pH. Yes.
And then for the second one, the H3O plus.
Oh, same.
Am I right? What'd you get? 4.4. I got the 3.5. And then I got
Oh yeah, your guys' was actually easier than theirs.
Did I do it right? I got 4.4.
I don't know. Here, let me.
How do you do that? How do you do the second one? I use the first equation.
So you have what for the first one?
3.5.
Mm-hmm.
Okay, I'll do some. Why did I get a different answer?
The second one would just be 3, wouldn't it? The negative log of 1 to the
Yeah, that's what I got.
times 10
But why did we just say, why
to
did
the negative third.
But why do we have this then?
Yeah, that's all you got. That's if you know the pH and you're looking for the hydrogen concentration. Yeah, you just use that both times. Okay. Yep. Wait, why? 2.9. I just got. It should just be 3. Because it's 1.0 instead of. Oh yeah, you have 1.2. Yep. Yep.
Because that's your OH, that means your H3O is going to be 10 to the negative.
All they had to do on the first one is take negative log of those two numbers separately. So they took the negative, for the initial, it was negative log of 3.2 times 10 to the negative fourth. And then negative log of 1 times 10 to the negative third. That's it. Mm-hmm. I know, and they were complaining that. There you go.
H3O is acid. Is like the acid amount.
See that, Mikey? See that handwriting?
Look at your chart.
Beautiful. Way better than yours.